In question 1, the coefficient of x cube in the expansion of p plus 1 upon px to the power 4 is 144. We have to find the values of the constant p. Now, when we're expanding an expression of the form a plus b to the power n, the formula is a to the power n plus nc1, a to the power n minus 1, b to the power 1, plus nc2, a to the power n minus 2, b to the power 2, and so on. Now, as we need x cube and x is with b over here, so we'll have to use b to the power 3. So using 4c3, in place of a, we have p, so that will be p to the power 4 minus 3, so that will become 4 minus 3, and b, which is 1 upon px, this will be to the power 3. So 4c3, when we apply it to the calculator, that will become 4. This will become p into that, this will become x cube upon p cube. So the coefficient of x cube over here is 4 upon 4p upon p cube, and that is equals to 144. So p and p cube will cancel. So this will become 4 upon p squared equals to 144. We can write p squared will be equals to 4 upon 144. So p square will be equals to 4 upon 144, that is 1 upon 36. Taking the square root of 1 upon 36. So square root of 1 upon 36, as it asks for the possible values, so p will have possible values plus 1 upon 6 and minus 1 upon 6. In question 2, the diagram shows part of the curve with the equation y equals to p sine q theta plus r, where p, q, and r are constants. In part A, we have to state the value of p. Now, as p is the amplitude, which is from the center part of the graph to the highest part or the lowest part. So we can see that the center part is at minus 2 till 1. So that height will be equals to 3. So p will be equals to 3. In part B, we have to state the value of q. Now this q is basically the number of revolutions of the sine graph in 2 pi radians. Now we can see that over here, the sine graph is basically making half a revolution in 2 pi and one complete revolution in 4 pi. Now, as q represents the number of revolutions in 2 pi radians or 360 degrees, as it is making half a revolution, it means that the value of q will be equals to 1 upon 2. In part C, we have to state the value of r. Now, r is basically the translation of the sine graph over here in the y direction. Now, normally the sine graph starts at the origin, which is 0, 0. We can see that it has moved 2 units downwards, which means that the value of r will be equals to minus 2. In question 3, an arithmetic progression has first term 4 and the common difference d. The sum of the first n terms of the progression is 5863. We have to show that n minus 1 into d is equals to 11726 upon n minus 8. Now, as the sum of the first n terms is 5863, so we know that the sum formula is n upon 2 into 2a plus n minus 1 into d. So the sum is 5863. So this will be 5863 is equals to n upon 2. And as a is 4, so that will become 2 times 4, which is 8, plus n minus 1 into d. So we can expand it and write it as, so as you don't have to expand it, it says that show that n minus 1 into d. So we can leave n minus 1 into d as it is. Now multiplying 5863 by 2. So 5863 multiplied by 2 is 11726. So that will be 11726 is equals to, so this is n into 8 plus d into n minus 1. Now we'll have to make d into n minus 1 the subject. So first dividing 11726 by n. So this will become 11726 upon n is equals to 8 plus d into n minus 1. Now taking 8 on the other side. So we'll get d into n minus 1 will be equals to 11726 upon n minus 8. In part B, it says, given that the nth term is 139, we have to find the values of n and d, giving the value of d as a fraction. Now, as it is an arithmetic progression, the nth term is given by the formula a plus n minus 1 into d. Now the nth term is 139. So we write 139 is equals to a is 4. So this will become 4 plus n minus 1 into d. So taking 4 on the other side, this will become 135 is equals to n minus 1 into d. Now to find the value of n and d, we can use the previous form that we have, which was d into n minus 1 is equals to 11726 upon n minus 8. So in place of n minus 1 into d, we can write 135. That will be equals to 11726 upon n minus 8. Taking the LCM, this will become 135 is equals to 11726 minus 8n upon n is equals to 135. Cross multiplying, we'll get 135n. Taking 8n on the left hand side now, this will become plus 8n is equals to 11726. So 135 plus 8 is 143n is equals to 11726. Now 11726 divided by 143. So the value of n will be equals to 82. Now once we have the value of n, now we can find the value of d, as the nth term was 135 is equals to n minus 1 into d. So now we can apply 135 is equals to, so that will become 82 minus 1 into d. So 135 will be equals to 81d. So d will be equals to 135 divided by 81. We can divide the 135 and 81 by 27. So that will become 5 upon 3. So the value of d will be 5 upon 3 and the value of n will be equals to 82. In question 4a, the curve with the equation y equals to x squared plus 2x minus 5 is translated by minus 1 and 3. We have to find the equation of the translated curve, giving our answer in the form y equals to ax squared plus bx plus c. Now, when we have a translation in the x and the y direction, so let's say if you have a function y equals to f of x, if there's a translation in the x direction and the movement is of a units, so we write it as y will be equals to f of x minus a. And if there's a translation of a units, or let's say in this case b units in the y direction, it means we will add b to the complete function f of x. So in this case, y will be equals to f of x plus a. So as we have both the translation in the x and the y direction, so this will be y equals to, in place of x, we will write x, x minus 1. So this will become x minus 1. So this will become x plus 1 whole squared plus 2 into x plus 1. This was a minus 5. And as is a translation of plus 3, so we'll write a plus 3 up here. Now expanding the expression, we'll get x squared plus 2x plus 1 plus 2x plus 2 minus 5 plus 3. Simplifying this, we'll get y equals to, so x squared will remain as it is. 2x plus 2x will make it a 4x. 1 minus 5 is minus 4, minus 4 plus, so this is 1 plus 2, 3. 3 minus 5 is minus 2, and minus 2 plus 3 will make it a plus 1. So the equation will be y equals to x squared plus 4x plus 1. In part B, it says the curve with the equation y equals to, so the original equation is x squared plus 2x minus 5. Now it is transformed into y equals to 4x squared plus 4x minus 5. We have to describe fully the single transformation that has been applied. Now, as we are talking about a single transformation, it means that there is no stretch in the y direction, because if it was in the y direction, then we would have multiplied the complete function by the stretch factor for y. So as only we can see that the values of x has doubled, so we can say that it will be a stretch factor. So as only the values of x have doubled, we'll say that the stretch factor will be in x direction, and the scale factor will be equals to 1 upon 2. Now for stretch in the x direction, if we have a function f of x and there is a stretch, so if there's a stretch in the x direction of scale factor, let's say a, in the x direction, so that function basically, we divide the x values by a. So if there's a stretch factor of 1 upon a, then in that case, we multiply the value of x by a. So if we take the stretch factor as 1 upon 2, so for the original equation, y equals to x squared plus 2x minus 5. In place of x, we'll write it 2x. In place of x again, we'll write it 2x minus 5. So this will be equals to 4x square plus 4x minus 5. So basically, this represents a single transformation, which is a stretch factor in the x direction, and the scale factor will be 1 upon 2. In question 5a, we have to solve the equation 6 square root of y plus 2 upon square root of y minus 7 equals to 0. Now, to solve these kind of equations, we can start off by taking a substitution. So let's say we can take x will be equals to square root of y. Now, writing x in place of square root of y, we'll get 6x plus 2 upon x minus 7 equals to 0. Taking the LCM, we'll get 6x squared plus 2 minus 7x equals to 0, and the denominator will be x. So we can simplify the equation to write it as 6 squared minus 7x plus 2 equals to 0. Factorizing, we'll get 6x squared minus 4x minus 3x plus 2 equals to 0. Taking 2x common, we'll get 3x minus 2. And taking 1 common, we'll get 3x minus 2. Simplifying, we'll get 2x minus 1 and 3x minus 2 equals to 0. So the two values of x will be 2 upon 3, and x will be equals to 1 upon 2. Now, to find the values of y, as x was equals to square root of y, so taking whole square on both the sides, y will be equals to the square of x. So taking 2 upon 3 whole squared, so one of the values of y will be 4 upon 9. And taking the square of 1 upon 2, so the other value of 9 of y will be 1 upon 4. In part B, it says, hence solve the equation 6 square root of 10x plus 2 upon square root of 10x minus 7 equals to 0. Now, we have already solved the equation with y over here, and the values of y was 4 upon 9 and 1 upon 4. So we can say that 10x will be equals to 4 upon 9, and 10x will be equals to 1 upon 4. So finding the values of x for 0 to 360, first we'll take tan inverse of 4 divided by 9. And making sure that the calculator is in degree mode. So taking tan inverse, which is 4 upon 9, we'll get the basic angle, which is 23.96. And taking tan inverse of 1 upon 4, so tan inverse of 1 divided by 4 that will be equals to 14.036. So the basic angle will be 14.036. Now, making both of these basic angles in the positive quadrants of tan, so we'll be making 23.96 over here in the first quadrant and 23.96 in the, so tan is positive in the third quadrant, so we'll be making 23.96 in the third quadrant. Now, to find the value of x, we'll measure x from the x-axis anti-clockwise. So one of the values of x will be 23.96, and the other value will be 180 plus 23.96. So 180 plus 23.96 will be equals to 203.96. Now take for basic angle, which is 14.036. Again, we'll be making 14.036 in the positive quadrants of tan, which is the first quadrant and the third quadrant. So the other two values of x will be 14.036 and 180 plus 14.036. So that will be 194.036. And as we have to give our answer in angles to one decimal place, so this will become 24.0. This will become 204.0. And this will be 14.0. And this angle in 194.036 will become 194.0. In question 6, the function f is defined by f of x as 2x squared minus 16x plus 23 for x is less than 3. We have, in part A, we have to express f of x in the form 2 into x plus a whole squared plus b. So the original function is 2x squared minus 16x plus 23. And we have to convert it to the form 2 into x plus a whole squared plus b. So first expanding, we'll get x squared plus 2ax plus a squared plus b. Multiplying with 2, we'll get 2x squared plus 4ax plus 2a squared plus b, and that is equals to 2x squared minus 16x plus 23. Now comparing the coefficients on both the sides, the coefficient of x on the left-hand side is minus 16 and on the right-hand side it is 4a. So 4a will be equals to minus 16 and a will be equals to minus 16 upon 4, which is minus 4. Now comparing the constant terms, on the left-hand side it is 23 and on the right-hand side it is 2a squared plus b. So we will write 2a squared plus b will be equals to 23. Value of a is minus 4, so this will be minus 4 whole squared plus b equals to 23. 2 into minus 4 whole squared will become a 32. So b will be equals to 23 minus 32, which is equals to minus 9. So once we have the values of a and b, we can write f of x will be equals to, so in place of a, we can write minus 4. So that will become x minus 4 whole squared minus 9. In part B, we have to find the range of f. Now from the original function, which we converted to the form 2 into x minus 4 whole squared minus 9, we know that the turning points are at 4. The coordinates of the turning points are 4 and minus 9. So making the turning points on the x and y axis. So let's say this point is 4 and this point is minus 9. So the quadratic graph would be made like this, with the turning points at 4 and 9. Now, once we have the turning points at 4 and 9, we know that the least value of the graph is minus 9. However, if you look at the domain of f of x, that was x is less than 3. So x equals to 3 will lie up here. So first, we'll have to find the value of x at the value of function f of x at x equals to 3. So substituting x equals to 3 into the function, we'll get 2 into 3 minus 4 whole squared minus 9. So 3 minus 4 whole squared, that will become a 1. So 2 minus 9 will be equals to minus 7. Now, as x is less than 3, and we can see that the graph will always be going upwards for x less than 3. And this value at x equals to 3 is minus 7. So we can say that f of x will be greater than minus 7. In part C, we have to find an expression for f inverse. Now to find the inverse function for a quadratic function, we must always convert it to the complete square form. As we already have the complete square form, which is 2 into x minus 4 whole squared minus 9, we can find the inverse function by first writing y in place of f of x. So this will become y equals to 2 into x minus 4 whole squared minus 9. Now exchanging the values of x and y, we'll get x equals to 2 into y minus 4 whole squared minus 9. Taking 9 on the left hand side, we'll get x plus 9 is equals to 2 into y minus 4 whole squared. Now dividing it by 2, so x plus 9 will divide by 2, and that will be equals to y minus 4 whole squared. Taking the square root on both the sides, so this will become y minus 4 will be equals to the square root of x plus 9 upon 2. And finally, we'll take 4 on the right hand side. So this will become square root of x plus 9 upon 2. And the 4 will come here and this will become a plus 4. But as with the square root sign, we have to add a plus and a minus sign. So this will become 4 plus minus square root of x plus 9 upon 2. Now, for a function for f inverse to be possible, the range of f of x was greater than minus 7. Now, for the function to be great, the range of the function is greater than minus 7, which means that, or we can say that as the domain of the function was less than 3, so the range of f inverse as the f inverse function is 4 plus minus square root of x plus 9 upon 2. This whole value must always be less than 3. Now, if we take a plus value, the range of f of x will be greater than 4. But as the domain of a, so what we need to understand is that the domain of f of x is equals to the range of f inverse of x. So the domain of f of x was x is greater than 3, which means the range of f inverse of x will also be greater than 3. It was less than 3, so this will be less than 3. Now for the range of f inverse to be less than 3, there must be a negative sign up here. So if it was a positive, it will be 4 or more. So we'll write f inverse of x will only be 4 minus the square root of x plus 9 upon 2. So for this value, this will always be less than 3. In part D, the function g is defined by 2x plus 4 for x less than minus 1. We have to find and simplify an expression for fg of x. Now, f of x, we already know it is 2 into x minus 4 whole squared minus 9. To find fg of x, so in place of x, we'll write the function g of x. As g is 2x plus 4, so we can write 2x plus 4 in place of x minus 4 whole squared minus 9. So this will be equals to 2 into 2x. 4 minus 4 will become 0. So this will be 2 into 2x whole squared minus 9. 2x whole squared will become a 4x squared. So the final answer for fg of x will be equals to 8x squared minus 9. In question 7, the diagram shows a circle with equation x minus 2 whole squared plus y plus 4 whole squared equals to 20 and with center C. The point B has coordinates 0, 2 and the line segment BC intersects the circle at P. In part A, we have to find the equation of BC. Now, looking at the equation, we know that the center has coordinates 2 and minus 4. And B has coordinates 0, 2. To find the equation of BC, we can first find the gradient of BC. So that will be y2 minus y1, which is 2 minus minus 4, divided by x2 minus x1. So that will be 0 minus 2. So that will become 2 minus minus 4 will become a 6 divided by minus 2, which is equals to minus 3. Now we can use the point B, 0 and 2 to form the equation of the line BC. So y minus 2, y minus y1 will be equals to minus 3 into x minus 0. So this will be y will be equals to minus 3x plus 2. So this will be the equation of BC, y equals to minus 3x plus 2. In part B, it says, hence find the coordinates of P, giving your answer in the exact form. Now to find the coordinates of P, it is the intersection point of the circle and the line BC. The equation of the circle is x minus 2 whole squared plus y plus 4 whole squared equals to 20. Now to find the point of intersection, we have the equation of the line, which is y equals to minus 3x plus 2. Solving the two equations simultaneously, we'll replace in place of y, we can write minus 3x plus 2. So this will be x minus 2 whole squared plus, so in place of y, we'll write minus 3x plus 2, and this will be a plus 4 whole squared equals to 20. Simplifying, we'll first write it as minus 3x plus 2 plus 4 will become 6 minus 3x whole squared equals to 20. Now expanding the brackets, we'll get x squared minus 4x plus 4 plus, so 6 squared will be 36 minus 2 times 6 is 12 and 12 times 3 will be 36. So that will become 36x and 3x whole squared will become a 9x squared equals to 20. So 9x squared plus x squared will be 10x squared minus 4x minus 36x will become a minus 40x. And we have plus 4 plus 36, which is 40, and then 40, and when we bring the 20 on this side, this will become a plus 20 equals to 0. Dividing the equation by 10, we can write this equation as x squared minus 4x plus 2 equals to 0. Now to find the value of x, we can use the quadratic formula, which is minus b. So minus b will become minus minus 4 plus minus square root of b squared minus 4ac. So b squared will be minus 4 whole squared minus 4 into 2 into 1 divided by 2 into 1. So simplifying this, we'll get minus minus, this will become a plus 4 plus minus. So this will be square root of 16 minus 8 upon 2. As we have to give our answer in the exact form, so we'll not take the square root. So this will become 4 plus minus square root of 8 divided by 2. Now square root of 8, we can write it as, so square root of 8 is 4 into 2. So we can write it as 4 plus minus 4 into 2 upon 2. So square root of 4 will be 2. So this will become 4 plus minus 2 square root of 2 upon 2, which if we simplify it, this can be written as x will be equals to 4 divided by 2, which is 2, and 2 divided by 2 will be 1. So this will be 2 plus minus square root of 2. Once we have the value of x, now we can find the value of y using the equation of the line BC. So the equation of the line was y equals to minus 3x plus 2. Substituting x equals to, so in place of x, now we can write 2 plus square root of 2. So this will become 2 plus square root of 2 plus 2. Simplifying this will be minus 6 minus 3 root 2 plus 2. So y will be equals to, so minus 6 plus 2 will become a minus 4. So this will be minus 3 root 2. So this will become minus 3 root 2 minus 6 plus 2 is a minus 4. And substituting x equals to 2 plus root 2. So 2 minus root 2. So that will be, y will be equals to minus 3 into, so x will be 2 minus uh, 2 minus root 2. So the plus 2 multiplying minus 3 by 2, that will become a minus 6 plus 3 root 2 plus 2. So this will be, y will be equals to minus 6 plus 2 is minus 4. So that will be 3 root 2 minus 4. Now, as P has both of the coordinates as positive, so you'll have to choose the only the positive coordinates. So in that case, the y coordinate, this y coordinate cannot be taken. So the coordinates for P will be for the negative value of 2 minus root 2 for the x value and 3 root 2 minus 4 for the y value. In question 8, the diagram shows the curve with equation y equals to x power half plus 4x to the power minus half. The line y equals to 5 intersects the curve at the points a 1, 5 and b 16, 5. In part A, we have to find the equation of the tangent to the curve at the point A. So to find the tangent to the curve at point A, we already have the coordinates. We just need to find the gradient. So to find the gradient, we'll find the dy dx of the curve. So the dy dx will become multiplying 1 upon 2 by the coefficient. So this will become 1 upon 2 x to the power minus 1 upon 2. Multiplying minus 1 upon 2 by 4. So that will become minus 2 and x to the power minus 3 upon 2. We can write it as 1 upon 2 square root of x minus 2 upon x to the power plus 3 upon 2 for dy dx. Now at a, the x coordinate is 1. So substituting x equals to 1, we'll get 1 upon 2 minus 2 upon 1. So 0 0.5 minus 2 will become minus 1.5, or we can write it as minus 3 upon 2. Now finding the equation, we know that the point is 1, 5. So y minus y1, this will be 5 is equals to minus 3 upon 2 into x minus 1. Cross multiplying, we'll get 2y minus 10 is equals to minus 3x plus 3. And we can simplify to write it as 2y is equals to minus 3x plus 3 plus 10, which is plus 13. In part B, we have to calculate the area of the shaded region. Now to find the area of the shaded region, we can first make a straight line from A and a straight line from B. So we'll have to find the area under the line. Now the area under the line is basically a rectangle. We know that the y coordinate is 5 and the base will be, so this is 16 and this is 1, so this will be 15. So the area of the rectangle will be 75. To find the area under the curve, which will give us this area, we'll have to integrate and substitute the limits 16 and 1. So the equation of the curve is y equals to x to the power half plus 4x to the power minus half. Now integrating to find the area, we will integrate with the limits 16 and 1. And the equation is x power half plus 4x to the power minus half Now integrating x power half, so that will become x to the power 3 upon 2, and we'll divide it by the new power, which is 3 upon 2, plus increasing 1 upon 2 by 1, that will become 1 upon 2, and we'll divide it by 1 upon 2. We can simplify to write it as 2 upon 3 x to the power 3 upon 2, and 2 will multiply by 4, so that will become 8x to the power 1 upon 2. Now substituting x equals to 16 as the upper limit, so this will become 2 upon 3 into 16 to the power 3 upon 2 plus 8 into 16 to the power 1 upon 2, and then subtracting it from the lower limit, which is x equals to 1. So this will be 2 upon 3 into 1 to the power 3 upon 2 plus 8 into 1 to the power 1 upon 2. So 16 square root is 4, and 4 cube is 64. So 64 times 2 will become 128. So this will be 128 upon 3 plus 8 times square root of 16 is 4. So that will be 32. And we'll have to subtract it from 2 upon 3 plus 8. So taking the LCM, we can write it as 128 plus 32 into 3, which is 96 upon 3, minus simplifying this, we'll get 2 plus 24 upon 3. So 128 plus 96, so 128 plus 96, that is equals to 224 upon 3, and this will become 26 upon 3. So 224 minus 26 is 198, and 198 divided by 3 will be equals to 66. So once we have the area under the curve, which is 66, the area of a rectangle was 15 times 5, which was equals to 75. So the area of shaded region will be the area of the rectangle, which is 75, minus the area under the curve, which is 66. So the final answer for area of the shaded region will be 9. In question 9, the diagram shows triangle ABC with AB equals to BC, which is equals to 6, and angle ABC is equals to 1.8 radians. The arc CD is a part of a circle with center A, and ABD is a straight line. In part A, we have to find the perimeter of the shaded region. So the perimeter consists of the straight line BC, the straight line BD, and the arc DC. Now, we already know that the line BC is 6. To find the length of BD, we need to find the length of AD. Now, AD will be equals to AC, as they are both the radius of the circle. And to find the length of the arc CD, we'll have to apply the formula S equals to R theta. So for that, we'll have to find the length of AC. Now, as two lengths and the angle between them is given, so we can apply the cosine rule to find the length of AC. So AC will be equals to 6 squared plus 6 squared minus 2 into 6 cos of 1.8. So 6 squared plus 6 squared minus 2 into 6 cos of 1.8, and then taking the square root, that will be equals to 9.40 centimeters for the length of AC. As AC and AD are equal, so we'll write AD will also be equals to 9.4. So as the length of AD is 9.4 and AB is 6, so the length of BD will be equals to 9.4 minus 6, which is equals to 3.4 centimeters. To find the arc length of DC, we'll apply the formula S is equals to R theta. Now to find theta in this triangle, we know that this is an isosceles triangle, which means that both of these angles will be equal. So we can write 1.8 plus 2a will be equals to pi radians. So to find theta, we can write 1.8 plus 2a will be equals to pi. So a will be equals to pi minus 1.8 divided by 2. So pi minus 1.8 divided by 2, the angle will be 0.6707. So a will be equals to 0.6707, or we can write it as 0.671. Once we have the angle 0.6707 or 0.671, the arc length will be R, which is, so the radius of the circle with center A, which is the length AC, so the radius is AC. So AC was 9.4. So this will be 9.4 multiplied by 0.6707. We always take the complete value when we are calculating and then round off in the end. So 9.4 into 0.6707 will be equals to 6.306. So once we have all these three lengths, we can find the perimeter by adding the length of BC, which is 6. So this will become 6 plus 6.306 plus the length of BD, which was 3.4 centimeters. Adding these three up, the perimeter will be equals to 15.7 centimeters. In part B, we have to find the area of the shaded region. Now, to find the area of the shaded region, we can find the area of the complete sector and then subtract it from the area of the triangle. So the area will be equals to area of sector minus the area of triangle. Now, to find the area of sector, we'll apply the formula. So area of sector will be equals to 1 upon 2 r squared theta. So the radius of the sector was 9.4 centimeters. So this will be 1 upon 2 into 9.4 squared multiplied by theta. So theta was 0.6707. Substituting this in the calculator, the area of the sector will be equals to 9.4 squared multiplied by 0.6707 and dividing it by 2, that will be equals to 29.6. So the area of the sector is 29.6 centimeters squared. To find the area of the triangle, so the area of the triangle will be found using the formula half AB sine C. The lengths are 6 and 6. So this will be 6 into 6 into the angle between. So the angle in between was 1.8. So this will be sine of 1.8. So multiplying 6 by 6 and then multiplying by sine of 1.8, that is equals to 35.05. Dividing it by 2, the answer will be 17.529, or we can write it as 17.3 centimeters squared. Finally, finding the area of the shaded region, we can just subtract the two areas. So area of shaded region will be equals to 29.6 minus 17.3. So the final answer will be 15.7 centimeters squared. Will be 12.1. So this will be 29.6 minus 17.3. That the final answer will be, so 29.6 minus 17.3 will be equals to 12.3 centimeters squared. Now, as I rounded off some of the values, this is not the exact answer as given. The exact answer was 12.1 centimeters squared. So this was the exact answer that was given in the exam, in the mark scheme. However, because I rounded off these values to one decimal place, so I got a different value. Now, giving this answer in the exam will result in a loss of -1. So it is better if we use the complete values when subtracting, when getting the final answer. Once we have the final answer, then we round it off to 3 significant figures. In question 10, the function f is defined by f of x is equals to 4x plus 2 to the power minus 2. In part A, we have to find f of x dx with limits infinity and -1. So first we'll have to integrate the function 4x plus 2 to the power minus 2. And the limits will apply are infinity and 1. So integrating this will become 4x plus 2 to the power. So we'll increase the power by 1. So that will become -1. Dividing it by the new power and multiplying it with the derivative of 4x plus 2, which is 4. So this will become 4x plus 2 to the power -1 upon -4. So we can write it as, we can take the negative sign up and write it as -1 upon 4x plus 2 multiplied by 4. Now applying the limit infinity and -1. So when we take x is equals to as infinity, so that will be equals to -1 upon 4 into infinity plus 2. and then applying x equals to 1. So that will be equals to minus 1 upon 4 into, so that will be 4 into 1 plus 2. So minus 1 divided by, so 4 into infinity will be infinity. 1 divided by infinity will be 0. So that will become 0 plus 1 upon, so this is 4 plus 2, 6. 6 times 4 is 24. So this will be 0 plus 1 upon 24. So the final answer will be 1 upon 24. In part B, it says that the point is moving along the curve y equals to f of x in such a way that as it passes through the points, its y coordinate is decreasing at a rate of k units, which means that dy dt will be equals to minus k, and its x coordinate is increasing at a rate of k units per second, which means that the dx by dt will be equals to positive k. It is saying find the coordinates of A. Now the equation relating dy dt and dx dt is dy by dt is equals to dy by dx multiplied by dx by dt. So we'll have to find the value of dy dx first. So the function f of x was equals to 4x plus 2 to the power minus 2. So finding the derivative or f dash of x will decrease the power by 1. So that will become minus, we'll multiply minus 2 first and decrease the power by 1. So that will become minus 3. And then multiply with the derivative of 4x plus 2, which is 4. So f dash of x will be equals to minus 8. And we can write 4x plus 2 in the denominator with the positive power. So now substituting this into the formula, the dy dt is equals to minus k. Dy by dx is minus 8 upon, so that is 4x plus 2 whole cube, and dx by dt is k. So k and k will cancel out, and both the negative signs will also cancel out. So this will be 1 is equals to 8 upon 4x plus 2 whole cube. Cross multiplying, we'll get 4x plus 2 whole cube is equals to 8. Taking the cube root of 8, we'll get 4x plus 2 will be equals to 2. So 2 minus 2 is 0. So the value of x will be equals to 0. Once we have the value of x, we can substitute it into the original function, which was f of x is equals to 4x minus 2. So the original function was 4x plus 2 to the power minus 2. Substituting this into the value of x over here, so we'll get 4 into 0 plus 2 to the power minus 2. 4 into 0 is 0, so f of x will be 2 to the power minus 2, which we can write as 1 upon 2 squared. So the value of f of x, or the y value, will be 1 upon 4. So the coordinates of A will be 0, 1 upon 4. Question 11, the point P lies on the line with the equation y equals to mx plus c, where m and c are positive constants. A curve has equation y equals to minus m upon x. There is a single point P on the curve such that the straight line is a tangent to the curve at P. In part A, we have to find the coordinates of P, giving the y coordinate in terms of C. Now, as they're intersecting and it is a tangent, it means there is only one point of intersection. So first we can equate the two equations and write it as mx plus c will be equals to minus m upon x. Cross multiplying will get, so this will become mx squared plus cx will be equals to minus m. Bringing the m on this side, we'll get mx squared plus cx plus m equals to 0. Now, as there is only one point of intersection, it means we can apply b squared minus 4ac equals to 0. So the coefficient of x squared is m, so a will be equals to m. The coefficient of x is c, so b will be equals to c, and the constant term is m, so c will be equals to m. Applying b squared minus 4ac, we'll get c squared minus 4 into m equals to 0. So c squared minus 4m squared will be equals to 0. We can write c squared is equals to 4m squared, taking the square root on both the sides. So the value of c will be equals to 2m. Now, as we have c is equals to 2m and we have to give the y coordinates in terms of m. So in the original equation, which was mx square plus cx plus m, we can write mx square plus c. So in place of c, we can write 2m x plus m equals to 0. Taking m common, this will become x squared plus 2x plus 1 equals to 0. So m will cancel out. We'll have equation x squared plus 2x plus 1 equals to 0. Factorizing this, we'll get the value. So we can use the quadratic formula to find the value of x. So this will be x will be equals to minus 2 plus minus. So that will be b squared. So that is 2 squared minus 4 into 1 upon 2 into 1. So x will be equals to minus 2 plus minus. So that will become 4 minus 4, which is square root of 0 upon 2. So the value of x will be equals to minus 1. Once we have the value of x as minus 1, we can find the y coordinate, which has to be given in terms of m. So in the equation, y equals to minus m upon x. So the equation of the curve was y equals to minus m upon x. We can substitute x equals to minus 1. When we substitute x equals to minus 1, we'll get minus m upon minus 1. So the y coordinate for point P will be y equals to m. We had to find the y coordinate terms of m, so y will be equals to m. In part 2, it says that given the normal to the curve at P intersects the curve again at the point Q, we have to find the coordinates of Q in terms of M. Now, the equation of the tangent was y equals to mx plus c, and the equation of the curve was y equals to minus m upon x. Now, for the gradient of the normal, as the gradient of the tangent is m, so the gradient of the normal will be negative 1 upon m. It is passing through the point P. So the point P had coordinates x minus 1 and y is m. So we can first make the equation for the normal, which will be y minus m will be equals to the gradient, which is minus 1 upon m into x minus x1. So that will become x plus 1. Expanding the bracket, we'll get y minus m is equals to minus x upon m minus 1 upon m, and then taking m on the other side. So this will be y equals to minus x upon m minus 1 upon m plus m. So we have the y coordinate over here in terms of x and m. Now to find the other coordinates, which will be the coordinates of q, we'll solve the equation simultaneously. So equating this, the equation of the normal with the equation of the curve, we'll get minus x upon m minus 1 upon m plus m is equals to minus m upon x. Taking the LCM, we'll get minus x minus 1 plus m squared upon m is equals to minus m upon x. Cross multiplying, we'll get minus x squared minus x plus m squared x, and this will be equals to minus m squared. Bringing the m squared on the left hand side, we'll get minus x squared minus x plus m squared x plus m squared equals to 0. Now, as we have to find the coordinates of q in terms of m, we'll factorize this. So we can factorize this part over here by taking minus x common. So this will become x plus 1, and taking m squared common over here, this will become x plus 1 equals to 0. So x plus 1, and this will become m squared minus x equals to 0. So the two values of x will be x equals to minus 1 and m squared minus x is equals to 0. So x will be is equals to m squared. Now, as we already have a x value minus 1, which was a coordinate of P, so the x coordinate of Q will be m squared. Once we have the x coordinate of Q, which is m squared, we can now find the y coordinate using the formula y equals to m minus m upon x. So y is equals to minus m upon x. As x is m squared, so this will be y equals to minus m upon m squared. M and m squared will cancel out, so the y coordinate will be minus 1 upon m. So the coordinates for q will be m squared and minus 1 upon m.